Hello everyone, I'm Jesslyn Jinisha from grade 8A and I'm here to discuss the types of combustion. First of all, what is combustion? When you see your mom cooking in the kitchen, you would see that on the stove there would be light and that is fire. But what happens to it? The fire is burning. This is called combustion. The scientific term for burning is called combustion. The rapid chemical combination of a substance with oxygen involving the production of heat and light is called combustion. What are the types of combustion? The types of combustion are rapid combustion, spontaneous combustion, and explosive combustion. First, let us take a look at rapid combustion. Uh, for example, when you see a candle burning, then when you light it, you would light the fire on the thread that is fixed on the candle. Imagine if there's no thread, would the candle burn? Of course not. Next, let's see if an LPG gas stove. In that, you have the LPG gas cylinder. So when you light the stove, it starts to burn. But imagine you're in a situation where you're cooking and you run out of gas. Would the stove burn? Of course not. You won't be able to cook. So you would buy a new cylinder and fix it. Then you would be able to light the stove again and it would start burning. In the same way, also in a kerosene stove, you would light the stove with the help of kerosene oil. If you don't have kerosene oil, then it is not possible. This is called rapid combustion. In rapid combustion, you would have large amounts of light and heat energy produced. Also, in this, you need an external energy source or an external source that acts like a fuel to start the combustion and prolong it. Now let us look at spontaneous combustion. Spontaneous combustion does not require any external energy to start the combustion process, unlike rapid combustion. This combustion starts spontaneously at room temperature itself due to self-heating. This reaction starts because of internal oxidation of the substance, which leads to thermal process, and if that particular substance reaches its ignition point and has high oxygen to start the combustion process, the substance starts burning on its own spontaneously. For example, in forest fires, there's no like external cause. Suddenly, when the temperature rises and like the temperature rises, and all of a sudden the forest fire starts and it spreads all over the place. But is there any fuel like petrol or diesel to make it burn? Of course not. It just starts on its own. Next, let's see phosphorus. Phosphorus burns on its own at room temperature. Isn't this a new fact? You know that all substances burn when you heat it. Like petrol or diesel catches fire when you like light it with a matchstick or when it heats. But this phosphorus, when in room temperature starts to burn, then how are you supposed to store it? Well, phosphorus is stored in under special conditions in special environments, and when it is brought out into the open, um, it starts to burn suddenly, and this is called spontaneous combustion. Also, this can happen in like alkali metals. So in alkali metals, they are like when they are outside, they are perfectly fine, unlike phosphorus. But when they are mixed with water, when they are brought into water, they start to burn. So, like this is the spontaneous combustion in alkali metals. Next, let us look at explosive combustion. Explosive combustion happens very rapidly, releasing enormous amounts of heat, light, and sound energy. This combustion process is simply can be said as an explosion. During this combustion, gases that are released will spread quickly, resulting in sound energy. Explosive combustion starts when some energy ignites the substance and heat, light, and sound energies are released immediately. So, for example, let's take the burning of firecrackers. When the firecrackers burn, you could see that the beautiful designs that you can see in the sky. Of course, everyone would know like the firecrackers. All of you might have seen it for Diwali or for any other festivals. But do you know that firecrackers is an example of explosive combustion? Yes, firecrackers burn and it produces light, heat, and sound. You might think, oh yes, I hear the boom sound when the firecracker bursts, and it produces the beautiful light, and we can also feel that heat in the environment. And also, during wars, we see the dynamite explosion. Of course, everyone would know that there are many deadly dynamite explosions that kill many people, and this explosion takes place with a lot of release of light, heat, and also sound. You hear a big boom sound, and also there's a lot of light energy, like you can see in the image that I've shown. So there are a lot of light energy, and also it's so hot that all the people would die, even if they're not present here. It would like the people might be standing very far away, but they would get affected by that heat. So it's that powerful, and all the atom bombs and the dynamites, they are all explosive combustion. So in explosive combustion, all of a sudden the substance starts to burn, and it also produces heat, light, and also sound energy. And you know why the sound energy is produced? It is because the heat, the light and heat is produced very fast. So when the rapid movement of the particles and atoms happen, the sound is produced. Now let us look at the differences between spontaneous and rapid combustion. Spontaneous combustion takes place spontaneously, while rapid combustion must be started by an external source. So we have already discussed this earlier. We need something like to start the rapid combustion, but we don't need anything to start the spontaneous combustion. No external energy is required in a spontaneous combustion, but in a rapid combustion, external energy is required. So as we discussed earlier, we need to light the candle to make it burn. But in spontaneous combustion, phosphorus just burns when you just bring it outside. And it depends on the ignition temperature of the fuel to start the combustion process. Like in phosphorus, that it has a low ignition point, so it starts to burn when you bring it to the room temperature. But when it's stored in its in special environments, it is totally fine. But in rapid combustion, it depends on the heat energy to start the combustion process. So like if you take any fuel that starts to burn, you have to heat it to make it burn. Next, less amount of heat energy is released in spontaneous combustion, and also less amount of light energy is released. But in a rapid combustion, a large amount of heat energy is released and large amount of light energy is also released. Because in phosphorus, it would just burn. But if you light the stove, like whoever might have tried cooking would have began your process by lighting the stove. When you're just hitting the lighter for a long time and it doesn't burn, and all of a sudden it starts to burn, you can see the rapid combustion. It just burns like anything, and you might have got scared. That refers to the large amount of heat and light energy that is produced. Next, let's look at the examples. Well, we've already looked at this, so you all know that for spontaneous combustion, phosphorus burns spontaneously at room temperature, and forest fires are also an example. Next, for rapid combustion, wax candle burns as soon as we give it an external energy by lighting the matchstick, and also the burning of LPG gas cylinders and also kerosene. So that's all for the types of combustion, and thank you. Meet you later.